Hello folks, this is Mr. Dan coming to you from the landscape design classroom, and today I'm here to talk to you about water culture and aeroponic hydroponic systems. The main idea here is what are water culture hydroponics and aeroponic hydroponics and how do they work? Now we've talked about this a little bit in the last few lessons about different types of hydroponic systems, but we're going to focus a little bit today. So the picture on our right here shows a simple water culture hydroponics unit. So as we can see here, the water is being recirculated down through, and you can actually pop the top on that to do your testing and stuff. So, and then you can see the clay balls underneath some of that, underneath the greens here, which are going to hold some moisture in there and help produce those root systems and also offer stability. So three main methods of hydroponic production. You have water culture, aeroponic culture, and agriculture. So today we're just going to focus on water and aeroponic. So water culture. So this is plants suspended in a nutrient solution, crown supported by a thin layer of inert medium, and a well aerated nutrient solution providing oxygen to the roots. So this is actually pretty typical of the system we're going to be using here in class, which is a PVC piping with holes in the top of it that you'll be able to see that you'll be able to pull the plants out of instead of pulling up like you can see in the picture down below. So these root systems will be growing through a nutrient solution that we talked about before, and will also be growing up through that thin layer of inert medium. So growing beds and troughs made of lined concrete, plastic, and another opaque inert material. So the inert material that we are talking about is what these are grown out of. So these ones look like they're grown out of either sawdust blocks or some kind of clay block. Covered beds to keep light out and prevent algae growth. So you want to make sure you keep those beds covered because once sunlight starts hitting those for a long period of time, you will get algae within your water. And most often used in a greenhouse. So if you're inside a building, you can use some other stuff, but this is really the best way to go if you are in the if you are growing within the greenhouse using a hydroponic system. So more about growing beds. About 20 to 42 inches wide, 6 to 8 feet deep, or 6 to 8 inches deep. Length normally under 100 feet. You can go above 100 feet, but I probably wouldn't recommend that. And then a slope of 1 to 2 degrees for drainage. So the system that we have has a continual slope going down the whole thing. You can get about 30 or 40 plants growing in, and then it recycles all that nutrient water back into the top and down through again. So it's a continuous recycling system. The materials used, plants started in perlite, horticubes, or other inert growing media. We've had students use all these down here in the class. We've actually even had them start plants in a paper towel before as well. So there are a lot of options for starting different plants. Transplants put into plastic mesh containers, as you can see in the photo on the right. May use styrofoam lids floating on the nutrient solution. And nutrient solution is 2.5 to 6 inches deep. So the more nutrient solution you have isn't necessarily the better. This is, I always say, make sure you are reading your labels and doing your research about your nutrient solutions in the plants you're trying to grow and achieve. Nutrient film technique. Roots in a plastic trough. This is a little bit more similar to what your system will be using, except we do have an angle on it. Continuous shallow nutrient solution. Very reminiscent of what we're going to be using in here. Most used for greenhouse vegetables and herbs. And then NFT materials, commercial troughs, plastic gutters, topped with pre-cut holes. So this is exactly what we will be doing in here. So, possible home units, PVC pipes with holes, vinyl rain gutter downspouts with holes. And trough length is usually under 100 feet. I think the length on ours is probably about 25 to 30 feet, which we'll be bringing that into the classroom and showing you how it works through that. So installed at 2 to 3 inch slope for a good flow. If you go over that, you're going to have a little bit harder flow, but I've seen some systems work with that. So a closed hydroponic system, nutrient solution continuously recycled, efficient use of water and nutrients, effective in arid areas, allows close monitoring and adjustments, and easy to add insecticides and fungicides. So the unit we have in here rotates around a whole bunch of times, and we actually keep our pump in the bottom of it, and it recirculates the whole way through the top, which will allow you to continue to have good continuous flow. So then you'll be able to dump your solutions right into the container at the bottom. The drawbacks of a closed system, possibility of spreading waterborne diseases. If you get a disease in that system, you want to make sure you're using the right chemical or approach to get rid of that. So high cost, complex equipment, complicated to operate. So not all systems are super complicated to operate. I know our nutrients might cost a little bit more to put in, but our product at the end of the day typically tends to be far superior. Now, a little bit more about NFT production. Water stress is not a problem. Can achieve tremendous production and multiple crops year round. So these type of systems will get you crops all year round, especially if you're in the well lit and treated greenhouse. So an aeroponic culture, this is a little bit more expensive. Nutrient solutions sprayed or misted on the roots of suspended plants. So these suspended plants, you're going to have water going up through that tube that's going to mist all over the roots of that plant, and we'll keep it alive that way. But you do end up getting dried out roots from time to time, so you need to check those continuously. Very little growing medium involved, and increased oxygen levels. So like I said before, it uses less water, but that can be a problem sometimes. Drawbacks of aeroponics, mineral buildup, more vulnerable to plants dying out, and may need more management. We've talked about this in the past, and I think we actually did the same exact slide in our last presentation. So I'm going to skip over this for now. So aeroponic, efficient use of space, vertical production. Plants are stacked several feet high. More plants per square foot, used as green or living walls for environmental benefits. Usually aeroponic, we won't really touch on that too much in here because we're going to be using more of a water closed system, but these are great for if you don't have a lot of space to work with. So that is the end of my presentation. If you have any questions, you can contact me down here in the Landscape Design Classroom. But I appreciate your time today, and have a great day, folks.